for the course is STA 4102, right? Time series analysis. Time series analysis. Now, today we are going to begin. Today will be our first class on time series analysis, and the topic itself that we are going to be looking at is time series analysis. Okay? The topic I'm going to take is time series analysis, and I have my intentions for taking it as time series analysis. Okay? When I say the first topic is time series analysis, it's because I want to do certain things which give completely a background on the course itself. So there are several items we are going to be discussing, starting with number one. Number one is why is time series analysis what do you call it, needed or necessary? Why is time series analysis necessary? Okay, I want to explain something as I want to take this as my introduction. Is it clear? It is just like planting on a farmland. You don't start planting on a farmland by just going straight into the definition. I feel that an approach to this course is best start what do you call it? It is best we start from, in our approach to the course, it is best we start from telling the students why this course is relevant, where it is applicable, why it is needed in both statistics and outside statistics. Is it clear? Then after doing that, we can now go to 2. So we can call this 1.1, we can call this 1.2 under topic 1. Okay? In subtopic 2, we now define time series analysis or time series. We start with defining time series, or what you can call a time series data. Now, in 1.3, we will talk about what we call components of a time series. Components of a time series. Then, once we are done with that, we would move over to 1.4. 1.4, we will discuss the graph of a time series. A time series data or a time series. Then 1.5, in 1.5, we will look at estimation of trend. Estimation of trends. Okay, so these are 5. I'm going to put a 1.6 for now, and the 1.6 will be exercise or examples and exercise. Is it clear? That's how I want us to progress. Now, in today's class, even as I've outlined all these, within 1 hour, we may not be able to go through all of them. Do you understand me? So, as such, out of these 6 items here, I am confident if we are fast enough, we will look at number 1. We will be able to achieve number 1, in which case we have to deal with what? Answering the necessity for time series as a technique in statistics, as a course in statistics. 2, we should be able to define a time series and also explain same. 3, we should be able to treat this and explain them. 4, we should be able to get this done. Is it clear? I'm supposed to, let me do this. Let me clean this off. I'm going to write it again, please, because there's something I would love us to even deal with. 1.5, let's put here 1.5 time series analysis. Okay? So even as the topic is time series analysis, all these here, the essence of explaining this and this and this is to help you understand this. Okay? So it is after this we now put 1.6 to be what was our 1.5 formally? So that is when you now do estimation of what? Trend. Okay? So sorry for that. Then 1.7 will now be examples and exercises. I hope it's understood. So we should be able to get to this point. This is my target for this class, to stop here at 1.5. So quickly, without waste of time, let us now go over to, let's go over to the first one. Okay? So question is, why is time series analysis necessary? Why is time series analysis necessary? Please, I would love to dictate, but before you start writing anything, just listen carefully, okay? You could drop your pen down and listen. Now, you see, I'm going to make my statements under this preamble in 3 paragraphs, basically. I may add an extra paragraph, but to communicate what I want to say or have to say under here. Is it clear? Now, please take note. Number 1, the course, time series, as a statement, is the title of a course. Is it clear? In the university curriculum. Time series as a statement is also the title of a topic, as you can see in what? In the course, STA 4102. Time series, again, as a statement, is also a subtopic, and let's begin from here. Why is it a subtopic? Appearing as a subtopic in 1.5 tells you that it is a statistical technique. Do you get me? So whether you are seeing it as a course, you are seeing it, you are to approach it as a course, approach it as what? A topic or a subtopic. It boils down to being a statistical what? Technique. Is it clear? Now, we've come, when you say it is a statistical technique, please let's be very precise. It is a statistical technique for analyzing data. Now, the previous, be it at 200 level, 300 level, or possibly 100, you may have been told at 100 level, or you may have been shown at 200 level and 300 level of your studies different statistical what? Techniques that are applied on what? Data, or applied to data. So, analysis of variance is a technique you must have treated that helps you analyze what? Data. The t-test is a statistical technique that has been applied to what? Data. You have also used numerous techniques in experimental design, numerous techniques in sample survey, techniques in econometrics to analyze what? Statistical data or data. Now, the question is, out of all those techniques, what makes time series necessary? What makes time series as a statistical technique different from those techniques we've looked at previously, or you are currently looking at in other courses that you are studying at the moment? It is the fact that the kind of data to which you apply time series analysis as a statistical technique is a time-dependent data. Is it clear? So when specifically your interest is on a time-dependent data, especially when the data is very large, you possibly may have to go with what? A time series analysis. For instance, let's assume that the data you are looking at is rainfall data for the period for over 10 years. You are looking at rainfall intensity. You want to see the pattern, especially when you want to know the pattern with which a particular occurrence has been occurring. Do you understand me? A particular event has been occurring over a long span of time. If you want to consider the rainfall intensity for over a period of 10 years, or the population explosion for over a period of 20 years, or a particular variable is to be observed over a long period of what? Time, provided the data is or the data are observations on a particular variable to be studied over a period of time, the most suitable technique, especially when you want to unravel patterns, is what? Time series analysis. Is it clear? So if I present to you a data and you don't have an understanding of time series or panel data, you may end up using a wrong analysis for the right data, or be using a wrong the right analysis for what? The wrong data. Is it clear? So it is very necessary as we begin this course to start from discussing what? Why time series is what? Necessary. I hope you understand me. So please, let's write. Time series analysis, be it as a course, a topic, or a subtopic studied in statistics, studied in, let's put, mathematics or statistics, studied in mathematics or statistics, is a very important statistical technique that is particularly suitable for analyzing data pattern for a large volume of time dependent observation, For this reason, time series analysis has become an indispensable statistical tool for use in society at large. Full stop. That's my first paragraph. So everything I have said so far, some of them are captioned in this statement. Please take note. Time series analysis, be it as what? A course, a topic, a subtopic studied in what? Mathematics or statistics. You are not the only ones who do, it is not in only statistics we do time series. Please take note. You get me? So in the broad field of mathematics, we also do what? Time series analysis. Take note, in any of them, in any case, it is a very what? Important statistical technique that is particularly suitable. Okay? Now, I have chosen that word carefully because you should know what time series analysis is really applicable to. It is particularly suitable for analyzing what kind of data? Data patterns for what? A large volume of time-dependent what? Observations. Is it clear? So that is the major reason why we embark on what? Time series analysis. Now let's take as an example, please, can I wipe this off? Now let's take as an example, in my next paragraph under that subtopic, let's take an example. For instance, if one were to study the pattern of rainfall intensity, over a long period of time, or the population explosion over a period, or the rise and fall of stock prices over a period of time, etc. Such patterns can be well explained and analyzed. Such patterns and what? Such patterns can be well explained and analyzed using what? Time series. Using time series analysis. So that will give you a clue. Those of you wanting to write a project on time series, you can now start thinking with a broad mind. Where my research, what kind of topic am I looking at? You get me now? Because you now know the kind of data you should be looking at. And that tells you that time series can never fail. Because when students come with a project topic, let's assume, you see, one of the most lovely areas to study, that is to write a project on, is one of them is time series. You know why? If a student picks up, let's say you are in a final year now, you won't be wrong to pick a project that someone has done previously in time series and the same data, only that the year has changed. Whenever we carry out a time series analysis, if you run the what do you call it, an analysis with the software, you may always want, in a typical project, you may always want to make projections for the next 5 years as one of your results. Do you get me? You may want to make projections for what? The next 5 years. Please take note that those projections are called forecasts. And those forecasts are usually not exact. They are usually not accurate. For instance, if you know 10 years, if you have a 10-year volume of data, and at the end of your project, after analyzing the time series, you now incorporate into the results of your findings a forecast for the next 5 years. Let's assume that your 10 years started from 2010, 210, 211, 212, 213, 214, right? 15, 16, 17, 18, 19. So those, you got data on rainfall intensity from 210 to what? 219. In your project, you now put a 5-year forecast. The 5-year forecast will begin from what? 2020 and end when? 2024, right? Now, if you now pick a project that was done such that the person used 2010 to 2019, and you pick such a project now in final year and want to carry out that same study again, you won't be wrong, because you shouldn't be using 2010 data. Now, you should use the 5 years he made as forecast and 5 years before then. Is it clear? And you won't be wrong, because as time changes, so also does the data in time series change. So it is something one has to be studying at every moment in what? Time. You get me? So time series data is usually a data that is very interesting to handle, because it is what we say, we're in that statement here. This statement here highlights everything. It deals with what? Time-dependent data. If the data we are handling or the observations we are handling are time-dependent, it means that as time changes, what happens to the data? It also changes. As the data changes, what happens to time? Time also what? Changes. Is it clear? Now, if you come to the second paragraph, you can now see certain examples. There are so many examples. For instance, if one is to consider, if your interest is to study what is the pattern of rain, take note. If in Calabar, we are taking rainfall intensity over the period of 10 years, over the period of 5 years, per month, I hope you know that the intensity we get per month for 5 years in Calabar cannot be the same intensity at Edo. It cannot be the same intensity as some other place. Do you understand me? So if you are writing a project on time series, you can even pick one on time series that was written in a particular place, because the data is a function of the location there and the time there, and also suit it to be your own by making it your location and what? Your own time. Is it clear? So for these two reasons summarized in 2 paragraphs, please take note, time series analysis is very, very necessary. let's go to the next thing. Is there any question? Is there any question? Let's go to the next statement. 1.2. What is 1.2, please? Good. So let us now define time series. So, definition of time series. Definition of time series. Who is that? Oh, HOD. Oh, come, sir. Fine. So, definition of what? Time series. Now, you don't necessarily have, if you want to define a time series, you may not just go straight into the mathematical definition of a time series. Is it clear? Before looking at the mathematical definition of a time series, look at the ordinary layman's definition of a time series. Okay. So, before looking at the mathematical definition, let's start with an ordinary sentence that describes a time series. Is it clear? So, the first definition under this, we are going to call it definition 1.2.1. Is it clear? So, please write a time series also known as a time series data is a set or collection of observations that are taken at different intervals, of time that are usually equal. Full stop. I'm going to explain what that means so that you don't think that it's the data that is equal. Not the data. It is the time space. Do you remember the bar chart? What's the difference between the bar chart and the histogram? I told you in year 1, 100 level. What is one feature, not by theory, what you see when you plot a bar chart? Good. So there are equal spaces between what? Bars in a bar chart. Is it not so? So, but histogram, there is no space between what? Bars. Now, what we say a time series is, if you don't want to say time series, when you hear us say, I've given you a time series, you could also interpret it as being given a time series data. Is it clear, everybody? So, when we talk about time series analysis, we are not referring to time series. Is it clear? Time series and time series analysis are two different things. Because by time series, you are referring to the data. And please, in some cases, time series could just be the course itself. Is it clear? It can be used as the title of the course. It can be used as what? Referring to the data. Okay? But in any case, please take note. It simply refers to a collection of observations. Please, I would even want you to even add this because it is very, very important. A set or collection of observations on a particular variable. On a particular variable, you can add that statement there. Just put an arrow on top. On a particular variable that are what? Taken at different intervals of time. It will make that definition more complete. Is it clear, everybody? So, now, if you look at it, this definition here, we are calling definition 1.2.1, gives credence. It gives foundation to the definition that is mathematical. Meaning that whether you give me this in the exam or you give me the mathematical definition in the exam, I will take any one. You are correct. Is it clear? But the reason why most times when we make statements in statistics or mathematics, we try bringing them to the level of a mathematical, using mathematical object, is simply because that one that is mathematically set out is one that can help you to develop theories, help you to prove theories, help you to solve problems or explain or model problems specifically. Is it clear? So please, Let us now move over to definition what? 1.2.2. Definition 1.2.2. So let's move over to that definition. Now, I prefer using that other rag. So definition 1.2.2. That is the second definition under 1.2. Okay. Now, a time series may be mathematically defined as a set of observations on a random variable y, y1, y2, y3 up to yn. Huh? On a random variable y at different times t that can assume t1, t2, t3 up to what? Tn. Based on this, we see that a time series may be expressed as a function y equals f of t. Let's call this equation 1. Is it clear? So if your random variable, if we use this collection of observations on a, you remember we said collection of observations on a particular what? Variable. If we call the variable y, for example, the one on rainfall intensity. When we say rainfall intensity, let y represent rainfall intensity. If you are now taking rainfall intensity as your random variable, the month of January could be T1. The month of February could be T2. That is the rainfall intensity for January could be regarded as what? T1. Whether it is the average rainfall intensity, you could call it what? T1. T2 could be February, T3, March, April is T4, and so on. So if you are considering it up to December, your n, this n here will be what? T12. Is it clear? So at the end of the day, mathematically, a time series is just an expression y equals f of t. It is a time dependent what? Data. So when we say it is a time dependent data, these are the observations y, and they are a function of what? Time. Is it clear? Good. Now let's go to 1.3. Let's go to 1.3. So what was 1.3? Components of a time series. Components of a time series. Components of a time series. Are we there? Now, the components of a time series are the characteristic movements. They are the characteristic movements. If you don't want to call them characteristic movements, you can call them characteristic variations. Okay? So they are the characteristic movements or variations, or you can call them trends. Okay? How many names did I call them? 3. They are the characteristic movements, characteristic variations, or characteristic what? trends exhibited by a time series data. Now, please take note. These components of a time series, are you listening? All of them can be exhibited by one time series data. Some of them can be exhibited by one time series. So it means that you can have a time series data on which you are going to perform a time series analysis. And in that time series analysis, you may observe one of these components that we are going to discuss to be absent or very mild. For example, in biology, we were told that, what do you call it? That traits can be dominant or recessive. Is it not so? So it can, and when traits are dominant or recessive in a particular generation, that trait may be exhibited by one member of the family in dominant manner, but in another generation, it will not even surface, but it's there. Is it clear? It is similar to what happens in a time series what? Analysis. There are what we call components of a time series, components of a time series, such that at not all the time will you have all of them, components of a time series, present in a time series data. That is in loud manner. They may be there, but or what you can call describe as being latent. And they may be there in loud manner. Now, the question is, if we say time series components or components of a time series are the characteristic movements or variations or trends exhibited by a time series, please, ordinarily we should have even made a statement, all or some of which are exhibited by one time series. The question now is, how many of them do we know as time series components? And what are their names? What do they mean? Is it clear? So let's quickly mention them. So we would say there are basically four types of variations. Types of variations or trends or characteristic movements. Of a time series. Am I wrong? Am I wrong? If we have just said that time series component refers to the characteristic movements or variations or trends, would I be wrong to say there are basically four types of variations, characteristic variations or trends or movements? I'm still referring to what? The same thing. In other words, I'm simply saying that there are four types of what? Components of a time series. Is it clear? Now, they are: one, we have what we call long-term variation. Long-term variation. If you call them long-term variation, I hope you know you can also call them long-term trend or long-term what? Movement. Is it clear? So if you don't write long-term variation, you can call it long-term movement. If you don't call it long-term movement, you can also call it what? Long-term trend. Is it clear? So long-term variation, another name for long-term variation is secular variation. Secular variation. Eh? That is the first time series component. And it is denoted with the letter, we'll put here at once, denoted by T. In time series, we use capital letter T or uppercase T to represent what is called a long-term variation. Am I understood, class? Is somebody following? Good. Now, the second variation we have, let's call that one I, and the next one is II. The second type of variation that is exhibited by a time series is what we call cyclical variation. Although you're not writing? What's the problem? Any problem? You are mourning? Is everything about this is okay? You appear to be very quiet and sober. If you were quiet, I won't even be bothered, but you are sober. What's the problem? Are you okay? Okay, thank God. Okay, so cyclical variation. Now, please, This cyclical variation is another component of what? A time series. If you don't want to call it cyclical variation, you can call it oscillatory variation. Oscillatory variation, denoted by C. Okay? Please, are we there? Denoted by C. Now, the third component of a time series is what we call seasonal variation. Seasonal variation. Okay? Now, this seasonal variation may also be called periodic variation. Periodic variation. And it is denoted by S. Okay? Then, number 4, we call it irregular variation, also called random variation. Okay? And this is denoted by I. Together, they give us the acronym TCSI. Okay? Long term, cyclical, seasonal, and what? Irregular variation. So, when we talk about the components of the time series, we are referring to the 4 of them: the long-term variation, the cyclical variation, the seasonal variation, and what? The irregular variation. Please, I hope you are following class. Now, you will notice that number 1 under this subtopic, what have we talked about? We did not just go into mentioning them, right? We started with describing to whoever listens to us what we are referring to as the components of what? A time series. Then, after answering the question, what are components of a time series? We now progress to what? Mentioning them. Is it not so? After mentioning them, or side by side mentioning them, we also make whoever will be listening to us or watching this video after now, we make them know that if there are substitute names or alternative names to calling each of these components, such that if you don't want to call them long-term, you can call them secular. If you don't want to call them cyclical, you can call them oscillatory. If you don't want to call them seasonal, you could call them periodic. If you don't want to call them irregular, you could call them random. Is it clear? Now that we did that, we now went further again to making whoever watches this video after now, apart from those of you in class now, we made them know that each of these variations have a symbol, okay, representing each of them. So T represents long-term variation, C represents cyclical variation, S represents what? Seasonal variation, and what? I represents irregular variation. When you tell somebody, as we are going to see subsequently, remember somewhere in our subtopic we have what? One of the subtopics is what? One of the subtopics is time series analysis. When we come to answering the question, what is a time series analysis? You will come to see how a time series analysis relates to what? These components of a time series. Eh? So, let's now move over to the last thing I want to see under 1.3. What is the last thing to do under 1.3? We have to now tell ourselves what long-term variation means, what cyclical variation means, what seasonal variation means, what irregular variation means, as well as typical examples around you that each of them describe. Let's start with the first one. So we are going to call that 1.3.1. 1.3.1 will be dedicated to discussion on long-term variation, a brief discussion on long-term variation. So let's go to 1.3.1. 1.3.1. That is long-term variation. Please. So I'm going to write in simple statements so that we don't waste time. Long-term variations are the eventual or over time movement of a time series. Full stop. It is the long-term variation that tells you in a time series. Remember, the 4 of them are usually present, or out of the 4, you may have 3 present. It is the long term that tells you, okay, look at it this way. If I present a data, let's take, are you listening? Let's take the price of fuel. Let's take the price of fuel from 1960 till date. Even as different things are happening to the price of fuel, even as fuel is fluctuating at different point in time, you will notice that irrespective of the fluctuation, from 1960 till date, the price of fuel has been upward. Is it not so? It has been upward. Even as it has been upward, take note, let's say from 1960 to 1965, it may have gone this way. Then it may have come down a little bit. But even as it came down in 1966, the price in 1966 it came down to is certainly higher than the price at 1960. So even as it came down a little bit in 1966, if you look at it, the price at that time is greater than the price at 1960, and it has been going upward. That eventual, what do you call it, movement, or the overtime movement of a time series data is what we refer to as this characteristic. Is it clear? So we say a long-term variation or the long-term variations are eventual or overtime movement of a time series. It is that part of a time series or component of a time series that explains whether the movement or the trend has been upward or has been what? Downward. In which case you would hear an upward trend or what? A downward trend. Is it clear? Now, so examples of this trend or this what do you call it? This feature is seen in the upward or downward trend description of any time series data. Full stop. So this particular component of a time series does that for you. It tells you over time, has the trend been downward? Over time, has it been upward, or has it remained what? Stagnant. Is it clear? This component explains that. Now let's go to 1.3.2. 1.3.2 is which one? Cyclical variation. So, do you know that even as the trend was over time upward, or over time downward, or over time stagnant, do you know that even as it is, it does not prevent a trend that is upward over time, or downward over time, or stagnant over time, can still be what? Cyclical. Is it clear? A trend that is upward, downward, or stagnant over time can still be what? Cyclical. It can still be oscillatory. It can still be what? Seasonal. It can also be what? Random. So being long term does not prevent the time series data from being what? Cyclical. Being long term does not prevent it from being seasonal. Being long term does not prevent it from being what? Irregular. Is it clear, everybody? Now, I was expecting a question at this point in time. Sir, one reason why do we, apart from what has been explained in relation to components of a time series, what one reason, in addition to what was explained earlier on, that necessitates time series, can you say? And I'm going to say this. Please take notes. Whenever you are performing a time series analysis in your project, if you carry out a project on time series analysis, one thing they would want to see is answering questions like, which out of these components were present? And which one did you eliminate? How did you eliminate them? So if there are cyclical components, I may want to remove cyclical components from them. Look at something. Let me show you something. See, when we get to time series analysis, what we call time series analysis, we will come to realize a time series analysis is a product, can be viewed as a product of T Ts, and what? I. And the aim of a time series analyst will be to do what? To smoothen a time series graph. And one way to smoothen the graph is to, if I want to smoothen a graph, it may be that I want to eliminate cyclical components. If I want to smoothen a graph, it may be that I want to eliminate what? Seasonal components. If I want to smoothen a graph, it may be that I want to eliminate what? Irregular components, if they are perceived as noise. Do you get me? What you call error. If they are perceived as noise, you may want to eliminate them. For you to eliminate them from a time series graph, look at it carefully. If I want to eliminate cyclical components, all I need to do is to divide by C. Use it. And what will remain? If I divide through by C, it will remain TSI. And the graph will no longer be a plot of y against these three. It will then be a plot of what? Y over C against what? TSI. So if I don't want to eliminate the cyclical component, but I choose to eliminate the seasonal component, what would I do? I will divide through by what? S. Do you see it? That process of doing this is a part of time series, and it is called a smoothing process. Am I understood? Yes. So let's go to the cyclical variation. Cyclical variation, please write. Let me dictate. Cyclical variations, also called oscillatory variations. Cyclical variations, also called oscillatory variations, are time series components. Cyclical variation, also called oscillatory variation, are time series components that explain how observations exhibit similar patterns. No, sorry, please correct that statement. That won't be proper. Cyclical variations or oscillatory variation are time series components. What did I say next? That explain, they don't explain similar patterns, please. Okay? Rather, put it this way, cyclical variation or oscillatory variation are what do we say there? Time series components that explain how observations of a time series oscillate about the long-term what? Variation, or the long-term trend. Put it at the long-term trend. That is the major function of the cyclical component. They explain how a time series data, observations of a time series data, oscillate about what? The long-term trend. Is it clear? Are we there? Yes, sir. Now, I'm going to show you with the graph how each of these look like, because I'm going to ask you in your exam. Do you understand me? And for knowledge sake. So, have you written that down? Sorry. Hello, Daniel. Good afternoon. Are we there? Yes. Now, please, underneath that statement, put as an example now. An example of a cyclical variation. An example of a cyclical variation could be observations of rainfall intensity, or population explosion at different intervals of time. Let me explain something. Look up. Please look up, everybody. The graph will make certain things very clear. Look up, everybody, please. Now, see, when we get into the graph of a time series, you will notice that from what we said that y is a function of what? Time. The graph of a time series is just a plot of what? Y against what? T. When we say long-term variation, it is usually a straight line for what is called a long-term, what do you call it? Line. It may also be called a long-term curve. Now, I would love to use broken lines to depict this. So if this is a long-term curve, remember what you did when you, do you remember what you did when you plotted a scatter diagram under regression and correlation? Do you remember? And I hope you know that when you carry out a plot of y against t, you would have values scattered all over the place. Is it not so? This long-term variation will now appear to be synonymous to what you call the line of best fit. You see it? Now, if you see the long-term variation as the line of best fit, a time series data could actually be like this. You may start having something like this. As your plot, you may start having something like this. Now, you will notice that even as this plot is going in zigzag manner, oscillatory manner, you will notice that even as it is going in zigzag manner or oscillatory manner, you can actually put a long-term variation or a long-term trend across that vibration, such that you will now see that the other points are actually going above and below that what? That trend line you have plotted. You see it? So what we call the cyclical variation are usually patterns exhibited like this, such that the observations go above and below what? They go about or oscillate about what? The long-term trend line. Is it clear? So that's what we are actually referring to. Now, it should not be confused. That is what I almost did. The cyclical variation or the oscillatory variation should not be confused with what? Seasonal variation. Am I understood? So, whereas cyclical variation is a component of time series that describes or explains how the observations of a time series oscillate about the trend line. Please take note. Let's go to 3.3 now. 1.3.3. 1.3.3. Kufre, please, I would want something similar to what we did last semester. You understand? You understand what I mean? I want something similar, starting from the first class and that other one. This is the first class for this one, right? Okay. Now, can we proceed to? I was thinking we would get to 1.5, but we may end up stopping at 1.3. So let's see how we can quickly round up with this. So cyclical variation. Are you there with seasonal? Okay, please write, everybody. Seasonal variation is a component of a time series. Seasonal variation is a component of a time series that explain. Seasonal variation is a component of a time series that explain or describe similar patterns. That explain or describe seasonal patterns that occur. Similar patterns that occur in a time series data. They are a component of a time series data that do what? That explain similar patterns that what? Occur at different time intervals or at different times in what? A time series data, full stop. Examples of observations that are seasonal in nature. Examples of observations that are seasonal in nature are those obtained on the prices of commodities during the Yuletide period. Examples of observations that are what? Seasonal in nature are observations obtained during the Yuletide, observations obtained on the price of commodities during the what? Yuletide period. That is Christmas period. comma, which other one? Yuletide, Yuletide, Yuletide. The Yuletide period, comma, and other festive periods. And other festive periods. Let me explain something. See, let me go back, come back to this graph. Look up, everybody. See, let's assume that from year to year is 2010. Listen, oh, please look up. If from year to year is 2010, let me show you what is happening. The first thing is that we are noticing that 2010, 2011, 2012. Let's just consider 3 years and see what is going on. If I want to ask you, what is the long-term price? What has been the pattern of the long-term price of what? A commodity like chicken during the Yuletide? You will tell me over the period of 2010 to 2012, it has always been on the rise. So that will be answered by the long term. Now, if I tell you, plot the observations you've taken on the price of chicken for those 3 years, you may be seeing something like this. You may be seeing something like this, such that it will be irregular in a way, but when it gets to December, despite how irregular it will be, you will just see a pattern like this. A very sharp high is what you will see. Then when you get into January of 2011, you will see something like this. Then when it gets to 2011 December again, or the ember months, what you call the ember months, you will see a very high one again. Do you understand me? Then coming to 2012, you will see, then it goes again in that manner. Notice these spikes are similar, and these spikes similar in different years at the same period of time is what we refer or are accounted to or accounted for by what? Seasonal what? Variation. But this oscillatory movement about the trend line is accounted for by what? Cyclical variation. Is it clear? Whereas this one here, even as it is oscillatory and what? Seasonal in nature, it has been what? Upward. As accounted for by what? Long term. Is it clear? Lastly, the next one is what? Irregular variation. Irregular variation. Irregular variation. Are we there? Irregular variation. So, irregular variations are components of a time series that describe sporadic movements. Sporadic movements of observations in a time series data. Irregular observations are components of what? A time series that describe what? Sporadic movements of a time series data. Somebody should give me an example or two. I want an example or two about irregular variations. Do you know that on one hand, crime, I will handle you out of class. Do you know that crime should be irregular? Do you know? But you will notice in recent time that crime, which should be irregular, crime should be something that is so sporadic such that it could happen once this year and not happen again for the next 5 years, and the same event can happen again. If crime becomes so regular such that it now becomes seasonal, it is a problem. There are some crimes in Nigeria that are seasonal. It is during the ember months that ritual killings become what? Heightened. Is it not so? Accidents should be random, but they are seasonal. During the ember months, they become seasonal. So there are certain activities, the activities we are referring to that has been irregular are those activities giving observations that should come from what? Sporadic occurrences, not regular occurrences, be it in form of seasonal, cyclical, or what? Long term. Is it clear, everybody? We'll continue from that place in the next class. Thank you very much.